Today you're going to forget all about the stress and difficulty of exams and learn how to see them as a challenge that can be successfully faced head-on. Hi, I'm Arjun Bhagat with another very special episode of Exam Special. So get ready to study smart with Topper as we share all the tricks, trends and tailor-made advices to help you ace the most important exam of your student life.
Today we will be focusing on chapter Application of Derivatives from the unit Calculus, which carries a whopping 44 marks in the board exams. That's almost half of the total paper, and therefore it's extremely critical that you spend a lot of revision time on it. Besides revision, it will also help you to know what kind of questions you can be asked. You must be prepared to face very small answer type questions for 1 mark or short answer type questions for 4 marks. While tracking the trends, we have observed that every year there has been a 6-mark question asked from this chapter. So you can expect one this year too. But also remember that the marking scheme has undergone a change since 2008.
Knowing trends is important to fortify your exam tactics, but they mean nothing if your basic concepts are not in place. So let's do a quick rewind of the key points from this chapter.
The key concepts from this chapter include the following: rate of change, approximation, increasing and decreasing function, tangent to a curve, normal to a curve, local maxima and minima, absolute maxima and minima.
I hope you're all clear with the basics. Now let's see what ability you need to crack these topics.
Any question from the application of derivatives may call upon one of the 3 abilities, that is, conceptual, numerical, or knowledge, with the first 2 ability types being the most important.
Now that we've gone over the building blocks of this chapter, it's time to start constructing our foundation for top marks. And what better way than to fully understand that solution which will serve as a prototype for many other solutions that you'll use in the exams. Let's check out today's model question, which is a conceptual 6 marks question that will require you to apply the rules of calculus as well as mensuration.
In this question, we have to show that the right circular cone of least curved surface and given volume has an altitude equal to square root 2 times the radius of the base. Here, since the volume of the circular cone is given, it means it's constant. We need to prove that the altitude is equal to square root 2 times the radius for a least curved surface area. So, let the radius, height and volume be r, h and v respectively. We already know that the volume of the cone is 1 upon 3 pi r square h. Now, we need to prove the relation of r and h with v as a constant. So, r square is equal to 3v upon pi h. This is the first equation. Now, we can write r square in terms of h. And what about the curved surface? Again, we know that the curved surface area of the cone S is equal to pi into r into square root of h square plus r square. Squaring both sides and putting the value of r square in this equation, we get S1 equal to S square, which equals 3 pi VH plus 9V square upon H square. Now, the question states that we need to prove that the altitude is equal to square root 2 times the radius for a least curved surface area. So let us find the first and second derivatives of S1 with respect to H. Now, for maxima and minima, we put ds1 upon dh is equal to 0. On solving it, we get h cube is equal to 6v upon pi. The second derivative of S1 is greater than 0. It means that the curved surface area is minimum at h cube equal to 6v upon pi, or v equal to pi h cube upon 6. On putting the value of v, we get h square is equal to 2r square, implying that h is equal to root 2 into r. Therefore, we find that for the least curved surface, the altitude is square root 2 times the base radius.
This model question is considered fairly difficult from the exam point of view, so I hope you understood it completely. Also, this question required you to remember concepts that you learned in earlier chapters and even earlier classes. So don't forget what you studied before just because you think that you won't be tested on it anymore. In fact, I like to think of mathematical concepts as a lifelong tool that can come to my aid at any time, and I try to keep them with me for as long as possible. So let's strengthen our concepts now by putting them to work in our practice session, because practice makes perfect.
In this question, we will find the intervals in which the function fx is strictly increasing and strictly decreasing. It needs you to find out how a function will behave at certain values of x, sometimes even without actual substitution. To find the interval, we first differentiate fx with respect to x and solve the equation for x. We find that x is equal to 3 and minus 2. Now, we get 3 disjoint intervals: minus infinity to minus 2, minus 2 to 3, and 3 to infinity. What do you find? We observe that in the intervals x less than minus 2 and x greater than 3, derivative of fx is greater than 0. We also find that for all x between minus 2 and 3, derivative of fx is lesser than 0. Thus, the function fx is strictly increasing on x less than minus 2 and x greater than 3. And we also find the answer to the second part of our question: fx is strictly decreasing between minus 2 and 3.
How's it going with you? Isn't it great to see your problems getting simpler? Well, we'll keep this practice on, but right now it's time to relax and refresh our hard-working mathematical grey cells. One of the ways I love doing that is by reading famous and inspiring mathematicians like the great Ramanujan, who shows us that maths can make you a topper in exams and beyond. So while I go and read up on my math heroes, why don't you try your hand at the breaking question? And I'll join you on the other side of the break with more practice questions, a HOTS question, and of course some exam tips specially prepared for you.
Today's breaking question asks you to find the angle between the curves y square is equal to x and x square is equal to y at 1, 1. Before the break, we'd asked you to solve the following. Find the angle between the curves y square is equal to x and x square is equal to y at 1, 1. Now, you know that the angle between two curves is the same as the angle between their tangents at the given point. So, first we find the slope of both curves at the same point, 1, 1. Let M1 and M2 be the slope of the curves and theta be the angle between these curves. Then tan of theta is equal to mod of M2 minus M1 upon 1 plus M1 into M2. On solving this expression, we find that tan theta is equal to 3 by 4. So we find that the angle between these curves at point 1, 1 is equal to tan inverse 3 by 4. Good work for getting that right.
Welcome back to the exam special on application of derivatives. Before the break, we studied past year trends and solved today's model question. We also solved 3 practice questions that were based on equations of tangents and strictly increasing and decreasing functions. Let's now take you through a few more practice questions in our segment, Practice Makes Perfect.
In this question, we need to find the intervals in which function f of x is strictly increasing and strictly decreasing. This question requires you to break the domain into intervals and check whether a trigonometric function is positive or negative in those intervals. So, to find the interval, we first differentiate fx with respect to x. On solving the equation for x, we find it is equal to pi by 4 and pi by 2. These 2 points divide the interval 0, pi into 3 intervals: 0 to pi by 4, pi by 4 to pi by 2, and pi by 2 to pi. Next, we find that f dash x is greater than 0 in the interval pi by 4 to pi by 2 and less than 0 in the intervals 0 to pi by 4 and pi by 2 to pi. What does this mean? This means that fx is strictly increasing in pi by 4 to pi by 2 and strictly decreasing in 0 to pi by 4 and pi by 2 to pi.
Next, let's solve a very small type question for 1 mark based on approximations.
Find the approximate value of square root of 25.2. We take fx is equal to square root of x as the base function. Then, fx plus delta x is equal to square root of x plus delta x. So find fx plus delta x equal to fx plus derivative of fx into delta x. We take x is equal to 25 as the number nearest to 25.2, whose square root we are aware of. Then delta x is equal to 25.2 minus 25 is equal to 0.2. Differentiating fx, we get 1 by 2 root x. And substituting it in 1, we get square root of 25.2 is equal to 5.02.
When you go to the board exam, you need to be prepared for any kind of twist. The same questions can be asked in different ways like the previous one. Let's now move on to our last question of this segment. Check it carefully as we show you how the same question can be asked differently.
A window is in the form of a rectangle, surmounted by a semicircular opening. The total perimeter of the window is 40 meters. Find the dimensions of the window so that maximum light is admitted. First, let's denote the different parts of the window. So let R be the radius of the semicircular part and let X be the length of the rectangular side. The question suggests that we have to find the dimensions of the window, which allow the maximum amount of light to enter. We know that the perimeter of the window is 40 meter. Also, since R and X are independent variables, we can eliminate one of them by substitution. So, the perimeter of the window is 2x plus 2r plus pi into r, which is equal to 40 meter. The area A of the window is equal to 2rx plus 1 by 2 pi r square. So let's substitute the value of x from the equation 1. We find that A is equal to 40r minus 1 by 2 pi r square minus 2r square. What does this imply? We can now express A as a function of r. The next step is to find first and second derivative of A with respect to r. Put the first derivative as equal to 0 for maxima and minima. This gets us the value of r as equal to 40 by pi plus 4. Also, we find the second derivative is less than 0 at r is equal to 40 by pi plus 4. So, the area will be maximum at r is equal to 40 by pi plus 4. This gives us the length and the breadth of the window as 80 by pi plus 4 and 40 by pi plus 4 respectively. If you want to practice another question like this one, then check out a similar one asked in 2008.
Give yourself a high five because you've just completed a rather challenging practice session. We've done questions based on approximation, increasing and decreasing function, tangent to curve, local maxima and minima. So congratulate yourself on a job well done and boost your confidence for what's up ahead, the HOTS question. Okay, it's time to fulfill my promise and tell you all about the HOTS question. If you've been following our other episodes, you'll know that HOTS stands for High Order Thinking Skills and refers to CBSE's innovative new question that will demand that you think out of the box.
Prove that the curves defined by x is equal to y square and xy is equal to k cut at right angles if 8k square is equal to 1. This question may seem unfamiliar to you, but don't panic. Its solution is based on concepts that you've revised many times over. So let's start by finding the intersection point of both curves, which we calculate to be k to the power 2 by 3, k to the power 1 by 3. Now, we find the slope of both curves at this point. Now we already know that the curves are perpendicular if the product of both the slopes at same point is equal to -1. On solving the equation, we find that 8k square is equal to 1, which is the desired result.
If you've grasped the nuances of the HOTS question, then that means you're now much better equipped to ace the exams than ever before. And just in case you missed any step or want to go to the problems that we discussed today, log on to our website www.topperlearning.com. You'll find practice problems and a lot more, including this list of extremely useful exam tips that's coming up next.
In problems based on maxima and minima, if a value is given in the question, take it to be a constant. Again, in problems based on maxima and minima, your first endeavor should be to figure out which variable is dependent and which one is independent. Express the dependent in terms of the independent variable Once you've split the domain into intervals in a question, asking for intervals in which a function is increasing and decreasing. Mostly the function will increase and decrease in alternate intervals. In maxima or minima questions, be careful and check whether you're being asked the point of maxima, which is the x value, or the maximum value, which is f of x, fx value. In 6-mark questions on the application of maxima and minima, 2 marks are reserved for substituting the value of x found into the second derivative to check whether it is positive or negative. Do not miss that step as it is a common mistake. Your examiner will be watching out for that specific step.
That brings us to the end of today's special look at application of derivatives and its possible exam questions. Well, we've given you all the building blocks for you to construct a successful exam game plan. Now it's up to you to work hard and use all the advice that we've given you to realize that potential that I know you possess. So keep striving hard and keep studying smart the Topper way. Take care and goodbye.